Hello! Today we're gonna talk about pairs. And I have two markers. Okay, cool. Two markers. Oh! Well, that failed. Okay. So we're gonna talk about pairs. Pairs of what? Angles and lines. We've talked about angles and lines in other videos. So now we're gonna talk about pairs of them. So let's start with lines, because they're easier to understand. So what could you think of on the top of your head? What types of pairs of lines are there? Well, there's ones that don't intersect, like these ones, and then there's ones that do, like these ones. Well, these both have names. This one is called a parallel line. Parallel. These ones are called intersecting. 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 So, parallel lines never touch. It's like this marker and this marker that I'm going to zoom across the screen. They are never going to touch. Even if they go across the earth and hit my face, they're not going to touch. Ever. Because they're parallel. One important thing, if you know much about the coordinate plane, is that parallel lines have the same slope. Because if they had any other slope, let's show an example. Let's have, say, this line x, this y, line x plus 1. They'd never intersect, because if we did an equation, x equals x plus 1, try to find their intersection point. I'll just move this out of the way. To find their intersection point and do the math, we get 0 equals 1, which is a contradiction, because 0 cannot equal 1, and that breaks the rules that we already have established. So, let's erase a little bit. Let's try and make sense of this. So, if parallel lines have the same slope, why do they not intersect? So let's say I have this slope A, then set it equal to, then have it equal to a constant K. K is a number, okay? That's one of our statements. K is number. Then we set equal to A plus N, and N is also a unique number. Another thing, K cannot equal N, because if they did equal each other, they'd be the same line. So, what do you think will happen? You cancel out the A's, meaning we got K equals N. And one thing we've already established is that K and N do not equal each other. So what happens is we got a thing called a contradiction. Contradiction! Da, 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 da. Okay. So, any other lines that follow this rule that have an intersecting point are called intersecting lines. And what we know from the postulate, if any two lines intersect, they intersect at one point. We know that they intersect at exactly one point. There's a special type of intersecting line that will be very common in geometry. It's called a perpendicular line. You might have heard it before. What's a perpendicular line? It's this. It's a line, two lines, that when they intersect, they are right. They're right angles. So it's like, one example of perpendicular lines, the graph. The graph has all perpendicular lines. My hand is trying to resemble a perpendicular line, but it's not doing that well. So, if you've ever looked at a graph before, you notice they're all perpendicular. They're all lines that never touch and lines that are perpendicular. So parallel and perpendicular lines are very important in the coordinate plane. And let's talk about slope for perpendicular lines. Perpendicular lines' slope is the opposite reciprocal. Opposite reciprocal. What does that mean? Well, if I have a slope of this line x, the line perpendicular to it would be negative 1 over x. This would be its slope. These are only for linear functions. Because lines can be perpendicular, only lines. Because these are perpendicular lines. They're not perpendicular parabolas. Which, yeah. So, let's erase the board. And now we're going to talk about angles. Pairs of angles. Actually, wait. We forgot one line before we end. We were about to start the other one. We forgot a line. One more line. These are called skew. So, what are skew lines? Skew lines are like parallel lines. But the issue is, they're not coplanar. What do I mean by this? Okay, let's say we have this plane. Okay, we got this plane over here. Now I'm going to try and draw another plane. Okay. Okay, we got 2 planes. Okay, and we're going to draw a dotted line, show that there's a boundary. So we got this line over here, then we got this other line over here. It might look like from here that they're on the same plane, but they're actually not. They're on different planes. This one's on plane P, this other one's on plane Q. And one important thing about parallel lines is that they must be coplanar, as in they have to be on the same plane, meaning these are skew lines. They skew the definition of a parallel line. This is why they're called skew lines. Not funny. Okay. Now we're going to talk about pairs of angles. Pairs of angles. Let's get some marker out. Put these away. So pairs of angles. Angles. So we have our angle here. So what would the pairs look like? Pairs that touch and pairs that do not touch. Well, that might be a good statement to say, but angles that do not touch do not have a name because they're made of 2 lines. We only have touching angles, aka touching angles. So there are some types like adjacent angles. And the other one is where the angles meet at one point, in which these are called vertical angles. Special thing about vertical angles. What is important about vertical angles? Vertical angles. So that they form opposite rays. What's an opposite ray again? So there are 2 rays that combine to form a line. Because this would be, so let's label these. A, B, C, D, E. So ray AB is a ray, but then ray AD is also a ray. They intersect at one point. When you combine them, they'll form line BD. Same with these ones. So then what's so special about vertical angles? Is that they're congruent. In a much later video, we'll actually talk about why they're congruent when we're going to prove them. But we don't know how to do proofs yet, so look forward to that in the future. So what about adjacent angles? There are 2 more types of adjacent angles. Complementary, and the other one, supplementary. Supplementary. So complementary and supplementary. Complementary is 2 angles that when added up form a right angle. So if you have a square where all the angles are right and you draw a line into it, then these 2 angles over here, the ones I've labeled, they would be considered complementary. Yeah, makes sense. What about supplementary? Supplementary. There's two angles that, when combined, form a straight angle, in which they're adjacent angles that add up to form 180 degrees, aka a straight angle. So those are complementary and supplementary. So, and one thing with pairs of angles and lines is that they can form bisectors. In the last video in the video before, we talked about midpoints and bisectors a little bit. So, adjacent angles can form angle bisectors if these two angles are congruent. If you can see these little slashes here, I put one slash, and if another angle has one slash, then they're both congruent. Then with lines, there's a special. We have bisectors, which are just formed by intersecting lines. Then with perpendicular lines, we got a special type of bisector. It's called a perpendicular bisector. Not an original name, but it's a perpendicular bisector. They're very satisfying. Like in the coordinate plane, they'll always form perpendicular bisectors. Like if I draw a coordinate plane, 1, 2, 3, 1, 2, 3, and then I draw out all these lines. They're not perpendicular bisectors, but that each of these shapes would be congruent. So I lied. Okay. So, what did we learn? We learned about pairs. Pairs of what? Angles and lines. Like these two. They're the same color. These two, they're not the same color, but they're the same. They're two. Got two? And we learned about parallel lines, lines that don't touch, perpendicular lines, lines that intersect, intersecting lines, which are not perpendicular, but they still intersect. Then skew lines, which break the rules of parallel lines, which skew the rules of parallel lines. Then we learned about pairs of angles, like adjacent, then the complementary and supplementary, and the vertical angles, which are formed by opposite rays. So, I hope you enjoyed this video, and we're gonna say goodbye. Goodbye.